Hey guys, in this video we are going to learn how to read a derivative graph, how we get all the information when a derivative graph is given. The derivative graph is positive as long as it is above the x-axis, because when it is above the x-axis the y values are positive. That means the derivative would be positive as long as it is above the x-axis. And we know that when the derivative is positive, the function is increasing. So we see that this function is increasing from negative infinity to 0 and then again from 1 to infinity. So the increasing interval are, and we see that the derivative graph is negative only from 0 to 1. Only for this interval the graph is below x-axis. That means the derivative is negative for this part. That means the function would be decreasing on this part. Then local maxima. A function has local maxima when its derivative changes from positive to negative. Here the derivative is positive because it's above x-axis. Here the derivative is negative because it's below x-axis, and the derivative is changes from positive to negative at 0. So it would have local maxima at 0, and the derivative is changing from negative to positive at 1. That means it would have a local minima at x equals 1. Now let us see how we get the information about second derivative when the first derivative graph is given. The slope of first derivative tells you about the second derivative. So as long as the slope of first derivative is negative, that means second derivative is negative. We know that the slope of a decreasing function is negative. So this derivative is decreasing from negative infinity to negative 2. That means the second derivative would be negative for this interval. And when the second derivative is negative, the function will be concave down on this interval. So the function is concave down first from negative infinity to negative 2. From negative 2 to approximately negative 1.25, it's increasing. The first derivative is increasing. That means second derivative would be positive, and when the second derivative is positive, it's concave up. So it's concave up from negative 2 to negative 1.25 approximately, and then from negative 1.25 to 0.5 it's decreasing again. That means the second derivative would be negative. The slope would be negative for this interval. So the function hx would be concave down on this interval. And then from 0.5 to infinity, the first derivative is increasing. That means the slope of first derivative, which is the second derivative, is positive on this interval. That means it would be concave up on this interval. So concave up from 0.5 to infinity. And now let's find the points of inflection. Points of inflection are those where the concavity changes from up to down or down to up. Concavity is changing at these points: negative 2, then negative 1.25, then 0.5. So these three are the points of inflection: negative 2, then negative 1.25, and then 0.5.